All right. Ooh. Let's see what we got going on today. So write linear equations given a point on the graph and the slope. And write linear equations given 2 points. So we've already worked a little bit with slope intercept form. So that top one probably wouldn't be too much work. But like if you're given 2 points on a graph, could you write the equation for the line that goes through both of them? And lastly, use linear equations to solve application problems. So using it in real life. All right, so let's go ahead and talk about what we got going on today. So we have point slope form. So to write an equation, given the slope of a line, so it's still m, it's still the same thing. It's still pretty much going to be the y equals mx plus b. So same thing, roughly. Slope is still m, and a point that passes through our given point, which they say is x sub 1 and y sub 1. So it's basically the same as the ordered pairs that we've been using of x and y. X is your sideways and y is your up and down. They want us to use this point slope formula. So here, and again, it looks a lot like the y equals mx plus b. It looks a lot like slope intercept form because there's y, but there's actually two y's here. There's an m, and then there are two x's, but there is also no b value. Now that b value, you're probably going to get that later. So again, it does look a lot the same. You just got to remember there's two y's, two x, and no b. So let's go ahead and practice using that. So here we have our first ordered pair. So it says it has to go through this point. And every point is made from an x and a y value. So let's plug it in. Now let's just start with y minus, and here we have y sub 1. That's the first point. So this is telling you use the point, which again, they give us an ordered pair here. So grab the y value from your ordered pair, which in this case is 7, equals m, which we know is -4, x minus, and then we have to use our other x value. So I'm going to put in -x like that. Now be careful because in this case here, there's a negative that comes with the formula, and this x will bring its own. So we end up with two negatives, a double negative. And you know, if you're pretty used to this, you could probably just substitute that in with a +1 or something like that. So sometimes I might end up just switching them, although I probably shouldn't. I think in some cases I can kind of get away with that. So I'm gonna take this double negative and turn it into a plus, just to make it a little bit easier to work with. Actually, it would be plus. Actually, I already also distributed as well. I think I can go ahead and do one step at a time. So actually, we didn't distribute now. So now be careful because again, in this case, there would be 3 negatives, so it might be confusing. So don't be afraid to write everything out. Y minus 7 equals, now I'm going to go ahead and multiply this out. So now you would see that this would be a negative that number here, because -4 times +1 would make it negative. So again, like I said, if it helps, don't be moving things. Now I'm just going to use some basic algebra here to get that 7 by itself. So in this case here, now I'm just going to add 7 to both sides, and I'm trying to make it look like y equals mx plus b. So y equals -4x plus 3, which actually that does look pretty much exactly like what we're trying to get. So that's going to be our formula that we need for this. And we can also double check it too, just to make sure that it works, because sometimes, you know, sometimes we just, you know, miss something's going on. But let's go ahead and move on to the next one. So if the next one here, I have our ordered pair of -6, -5, and our slope of 2/3. So we have a slope that is a fraction, and don't forget, if it's a fraction slope, it's going to be rise over run. So let's go ahead and plug it in. Y minus negative, and don't forget that if you want to put an x and a y here, because it is one of those things that I see all the time, that students will oftentimes switch these because, you know, x goes first, but in this formula here, the y is the one that goes first. X minus, and then we have to take our x value here, which is going to be -6, which is going to cause us to have 2 negatives. Okay, now let's go ahead and try to get this out. Now, it looks like I'm already running out of space here, so I might have to, again, skip a step or two. So y plus 5, because this is going to be, again, changed to a plus 2 over 3x. And this would be plus 6. So plus 6 times 2/3. And if you need to, you can go ahead and, let's see if I can just do this over here. So 2/3 times 6. And don't forget, you can turn it into a fraction by putting a 1 under it. And here I'd have 2 times 6, which would be 12, and then 3 times 1, which would be 3. So this is 12 over 3, which we can divide that. Remember, if you run into a fraction, divide it, and then if you can't do that, then you should simplify it. So in this case here, it looks like we can easily divide that. So that looks like we would have a positive 4, like that. Now I'm also going to have to get rid of this 5, because again, we want to make this into the y equals mx plus b formula. So -5 from both sides. And let's see if we can finish this out. So y equals, I'm going to write it down here in this corner. Just, I guess that's just where things have been ending up lately. 2/3 x minus 1. So this is our formula. This is the equation for a line that does go through these points and has that slope. And this one's kind of easy. It's just really just plugging things in and seeing if it works out. But for this assignment, you're going to be using the 2-point method a lot more. So in this case here, this is pretty easy because you're given 1 point and the slope. So it's really easy to put it into point slope and then slope intercept form. Yeah, all these equations kind of sound the same, but they're a little bit different. And again, point slope, pretty easy to remember because you're given a point and the slope. Okay, not that hard to confuse. All right, so let's go ahead and write a linear equation given 2 points. So it says here we have, like in this case, I would call this group 1. And here I would call this group 2. So what we'd have to do is we would have to find out our slope, because our point slope form does not work if we don't have a slope. So we're going to need to know what the slope is. So take the y's, and this is pretty easy because it's rise over run. Rise over run. So my top number is the y values, and it's pretty easy to remember because your y is the up and down movement of your line. And then your run, that's usually the left to right movement. Make sure you remember that if your slope is positive or negative, it should go in that direction. Once you have your slope, then you plug it into your point slope equation, your point slope formula. And that's pretty much what you would need to do. From here, it would be pretty much the exact same steps we did for both of these examples here. And like I said, it seems pretty tough, but I think it'll be pretty easy once you start working on it. So let's go ahead and move on to some of the other examples that we would have going on today. So here we have 2 points. So -6, 1 and -3, 7. So those are the 2 spots our line has to go through. So let's do what we're supposed to. Now again, we got x and y value, but we need one of these to be group 1 and the other to be group 2. You can kind of make this a little bit easier on yourself. What I like to do is to make the one with the bigger numbers, not necessarily the greater numbers, but just the ones that would normally be bigger, ignoring the positive and negative. So just not paying attention to whether they're positive or negative. This one has the bigger number, so I'm going to make that one go first. Now, if you want to, you could also make sure that your positive numbers go first or whatever, but a lot of times that really doesn't make a whole lot of difference. So anyway, let's go ahead and use our slope formula here. So y2, so that's telling us the y from group 2. So this one is group 2. There's the y, so that means our 7 It's gonna have to be our first number. And then we have here y of group 1. So minus 1, so 7 minus 1. Now we need our bottom numbers, x sub 2. So group 2, there's our x. And then x of negative 1, so here I have, there you go. 7 minus 1 is 6. And let's see, if it helps, you can go ahead and do this step again, because I'm going to change this to a plus. So if I have the two negatives, they will change sign into a plus. 6 over, and then 6 minus 3 is, well, 3. And in this case, we end up with a really nice slope of, well, because we can divide it, we get a slope of just 2. Now we have our slope, we have our m. Next thing we got to do is plug it into our point slope formula. So with our point slope formula, we got to pick one of our points. And it doesn't really matter, okay? You can pick this one or you can pick this one. And both of them will give you the same answer pretty much. So don't stress it too much, okay? But again, I'm gonna go with this one here, or maybe this one here. I'm gonna go with this one, yeah, definitely this one, because it has smaller numbers. And in general, you might have an easier time working with it. So I'm gonna go ahead and plug it in. So y minus, and then take the 1 here, because that's the one we need. And our slope is 2, right? The slope is 2, x minus 1, which in this case is gonna be negative 6. All right, there we go. So now we have to start working this down so it looks like the y equals mx plus b. So we should get our own b value after this. So distribute this out. So 2 times x is going to be 2x. And again, this is going to be plus 6. So plus 6 times 12. So that would be, I'm sorry, positive 6 times 2 is 12. There you go. And then from here, I would have to get rid of this here because again, I got to get this solved for y, which means I need the y by itself. And it needs to be in the y equals mx plus b form, which in this case, this one looks like it works out pretty well because it looks like it is in y equals mx plus b. And you see, again, we end up with our own b value here. So even though point slope form doesn't have a b value, you'll still end up getting it in the end. Okay, so let's see what we got here. Now, first thing we got to do is assign these to be group 1 and group 2, because it is a little bit easy to mix these up where they go. And that's usually one of the first things I see when I'm grading papers. I'll notice that sometimes students don't put the right number in the right place. So you can do what I did here and put x and y. Now you don't have to do this, but I do suggest that you do it because again, that's usually one of the easiest things that happen.
I know some of you are still having issues. If you're still having issues, please contact Michelle. Logan is on his way over.
All right, so again, make sure you just put these in the right spot. Let's see, group 2, so y2, so let's get our group 2, go with y, so 8 minus, and there's the y from group 1, so I'm gonna go ahead and put that in there. And then the same thing with the x's. Now again, this is like sometimes I'll see something like this and that's not right, okay, because you gotta put it in the right order. One easy way you can remember this is that the two numbers from the same group will be, lined up and down. So if I have 8 here, that means 6 is going to be below that one. And I kind of picked this one to be group 1. That way they'd both be minus 2 over here. That way I could do the same thing with both of them. Whereas if I did that one over here, I'd probably have to remember that one is positive and the other is negative. So if I wanted to, I could skip that step and just go straight to this step where I just reverse the sign. And then that way I can just, get to my slope a little bit faster. So 8 plus 2 is 10. 2 minus 6 is going to be negative 4. And in this case here, I have a fraction, but I can't really divide it. Well, so far we've been using a lot of mixed numbers, so you got to kind of know when to use mixed number and when to just leave it as a fraction. So in this case, I think I'm going to leave it as a fraction because remember, if you have a slope, it's much easier to look at your top number and say, okay, that's the rise and your bottom number is the run. Because if I put something like, in this case, it would be something like 2.5 or negative 2.5, that doesn't make sense. How do you graph that? Well, I mean, it's pretty easy once you figure it out, but it's way easier to graph something, especially if it's, well, in this case, it's 2.5, but you know, you might get something like 5 over 13, which is, or 13 over 5, okay? Which is gonna be a really tougher way to graph things. So just leave it as a fraction. And in this case, let's reduce this. And I'm going to reduce this, but I'm also going to do something else. I am also going to move the negative to the top. And I like doing this because it reminds people that the run is always from left to right. Your run should be positive because your lines are always going from left to right. And this also tells me that we are going to have a negative slope that is going to go down. All right, so anyway, now we have our slope. So let's go ahead and plug it in and let's see what we got. Now I'm going to use this group here. And again, you can have a choice. You can pick either one of these. So y, and I'm going to reverse the signs already just to show you what the shortcut would look like if you just sort of do this. And be careful because it is really easy to miss the sign. So again, they should be negative, right? Negative here, negative there. But because these are already both negatives, they end up with 2 of them, and I'm just going to switch the sign. So that's one way you could kind of do this to make it go a little bit faster, you know. But if you're not sure, if you're thinking that you might make a mistake somewhere, then, you know, just go ahead and write the whole thing out. So here we go. Let's see. 2 times 5 is negative 10. Negative 10 divided by 2 is 5. But again, that's pretty much the same trick we've been using to get rid of our fractions. Multiply it by the bottom number, and that's going to cause it to be gone, to go away. And again, you can pick either of these numbers, groups, this one or that one. And I think this one's a little bit of an easier one, just a little bit. But I still got to get rid of this number here. So to get rid of that plus 2, I'm going to have to minus 2 from both numbers. So I think we're done here. So y equals negative 5 over 2x minus 7. And we could use both of these. Let's test them out. So if you got your worksheet in front of you, let's test both of these lines out really quick. I'm going to go over to the internet. I'm going to go over to Desmos, which I already have it set up here. So let's go ahead and plug some of these in. So the first line we had was y equals 2x plus 13. So there you go. That's the answer we got for number 3. And let's test it out. So negative 6, 1. So this line should go through negative 6, 1. Which it does. Okay, it's a little bit of a fine adjustment to get there, but negative 6, 1, true. It does go through that line. The next one it should go through is negative 3, 7, which it looks like it does. And it does. So negative 3, 7. So that was our line number 3. And that's true. So both of them are true. So we know that we know that this one is a working line that will get us through those 2 points of negative 6, 1 and negative 3, 7. Let's go and do the other one. So in this case here, I'm going to have to plug it in using the, I think we said it was negative 5 over 2 x minus 7. And the 2 points it gave us were negative 2, 2. So negative 2, 2. So back 2, down 2. And it looks like we're actually going to get right. Oops, a little bit over. And again, sometimes it does take a little bit of fine adjustment to get to there. So negative 2, 2. Yep, does go through there. And the other point that it had the line go through was negative 6, 8. So let's do that. Negative 6, so back 6, up 8. And it looks like it does go right through there. Yep, there it goes. So negative 6, 8. it is true. It does go through that line. So we know both of these equations for problems number 3 and 4 are accurate. They should reflect what we see in the equation. So there you go. Again, these equations will have these points in them. All right. So let's go ahead and move on to the next one, and hopefully, well, we're not going to check all of them just because that would take a little bit of time to check everything. I would like to check every single one of them, but again, time permitting, probably not. So let's go ahead and just keep going. So here I have Y2. So there's a, now I'm going to do something a little bit different. I'm going to make this one group 2 and this one group 1. Just because, again, I usually like to have the group 2, the first group actually, be the one with the larger number. So in this case, I get 10. Oh, wait. See, that's why it's a good idea to mark out your X and your Y, because that is something that happens quite often with students. They will put the number they see first because they sometimes the order switches. Like in this case, we want the Y. So in this case here, that would mean I'd have to start out with -5. Which would mean that I have to plug in here, -8. And again, sometimes I skip, sometimes I don't. So I'm going to just leave this negative in there, the 2 negatives. And now I need to grab this one. So the X is going to be the bottom side because, again, that's our run. And so in this case here, I get -5 plus 8 over 9. All right, so 8 minus 5 would be 3, so 3 over 9. And again, anytime you run into a fraction, we want to leave it as a fraction, so don't divide it, okay? But let's reduce it. So in this case, 3 and 9 can be reduced to 1/3. So take your top number, divide by 3. Bottom number, do the same thing, divide that by 3 as well. So now we have our slope. Let's go ahead and plug it in. And I'm also going to pick one of these to go into our formula, which I'm going to pick this one here, which just so happens to be the one with the smaller numbers, and that's why it's group 1, so that's why I'm using it. And again, you can use either one of these. There's no wrong way to do this, really, as long as you follow these steps. So again, we could use this one, or we could use that one. So y equals, oh wait, sorry, y minus, and I need to find the y, so I'm using this one here. And I'm going to put in 8 because I already know that this is going to be a negative, and there's going to be a negative here, so it's going to be 2 negatives. 2 negatives make a positive, so 1/3 x minus 1. And make sure I pull them from the same group, because I've seen that happen where they'll pull like 8 from this group, but then they'll pull like 10 over here or something like that. So make sure you're pulling them from the same group. Now from here, we're going to go ahead and do the usual stuff. So I'm gonna divide it out. Y plus 8, sorry, not divide it, distribute. And now I got to get rid of this 8 here. So that's going to be -8 here and -8 here. And here we have a bit of a problem because, well, it's a fraction and we're going to be doing adding and subtracting with it. So, well, let's see what we got here. Okay, so they're both negative. And we know that if you have 2 negatives, you combine their value and just put a negative back on it, basically. Now this one's kind of an easy one because I have a whole number, a pure whole number, and here I have a fraction, pure fraction. When this happens, you can just place them together. Now be careful because there are some cases where this is not going to happen this way. Okay. So like just let me ask you a really quick question. And what is $8 minus a quarter? Now you might be thinking, well, wouldn't it be $8 and a quarter or something like that? Or $8.25 or maybe $7.25? Now I chose this example because I know that it's one of those ones that a lot of people will kind of mess up. But actually the real answer would be $7.75. So don't confuse it. Okay, kind of ask yourself, what does it mean? So in this case here, I am able to just say -8 1/3. So a bit of a weird one, but it kind of was a little bit easier than we might have expected. All right, so let's go ahead and box that answer and move on to the next one. Now again, we got to pick one of these to be the group 1 and group 2, which I don't know if that's going to make any difference or not difference. So I'm going to just go ahead and randomly pick it the same way I did the other one. So it doesn't matter which one's group 1 or group 2. So let's see, with group 2, that's our first one. So we need our 2 numbers. And like I said, if you pull them from the same group, they're going to be one on top of the other. So that's kind of the way I do it, just so that way it's not as, you're less likely to make a mistake of putting the wrong numbers together. Now here, don't forget this is your y, and that's the one we need on top. And actually that would be a -3. And this one would be a -2. So -3 plus 3, and right now I'm already kind of telling that there is something weird going on here. Because I am going to end up with a 0 on top. Now, when you have a 0 on top, that's a bit of a weird thing because, well, 0 divided by anything is always going to be 0. So that means that we just plain old have 0. It doesn't matter what our bottom number is going to be. You can take 0 and divide it by whatever number you want. It's always going to be 0. So how do we do this one now? Because our m is 0. Well, let's just keep going, right? I'm going to take my point here, plus 3. So make sure you're taking the y value, 0, and then x minus, because we have x minus, and then that's our point, which is going to be -2. So I'm just going to plug in plus 2 just to make things go a little bit faster. Okay, just make sure you watch your signs. If you have a double negative, make it positive. And if I distribute the 0, that's 0 times x, which is 0, and 0 times 2, which is still 0. And I'm going to have to minus 3 on both sides, and I get this line, which does not look like y equals mx plus b. But the question that we have now is this going to work? If I graph this line, is it going to have the point -2, -3, and -8, -3? Well, let's go ahead and go on to our graph, and let's see what it tells us. So let's graph out y equals -3, or y, oh wait, there's nothing at all here, so none of that is going to be there. So what does our line look like in this case? So let's, I'm going to click on this little house button, that's the home zoom, and we end up with a line that is flat horizontal. It's just going straight sideways. So does this at least contain the 2 points that we were looking for? So if you have your paper in front of you, the first one is -8, -3. Okay, we can zoom in to make it a little bit easier. There we go. So -8, -3. So yes, it does contain one of the points. So let's see the other point. The other point was -2, -3, which well, you could probably already tell what's going on. Zoom in some more. -2, -3, there you go. So it does go through both of those points. So this is a weird looking line, a weird looking formula, weird looking equation, but it still works. So we know that this is true. And that's kind of why I'm showing you guys how to get how to check it, how to use the Desmos to check it. So in this case here, that's true. That is a working equation for a line that goes through these 2 points. Now, one other kind of trick is that you notice that both y values are -3. And that's kind of a trick, that's kind of well, they are trying to trick you, but that is kind of a hint that this is going to be a flat line. All right, so let's go ahead and move on to the next one here. So those are just some examples on how you would write them down. So let's go ahead and look at how you would use some of these IRL, where you would use some of these. So applications of slope intercept form. All right, so this example, I'm not really sure how it works. One of these days I got to ride an Uber just to see what it's like. But in this case, we're talking about a cab, and cabs, I don't know if they're really that common anymore. I remember Flagstaff used to have cabs a long time ago, but you had to call them, and you know they weren't just driving around. They're not like in the movies where you can just put your hand out and get one to stop for you. But usually it goes something like this. If you call them, they will drive out to you, and they might even still charge you just for that. So let's say that you call a cab just to go down the road, like literally, you know, down the road. You're just going to go to the gas station and run inside and then go back out. Well, they're going to charge you $4 just to show up, and they're going to drive for each mile. They're going to charge you $1.75. So a cab ride costs $4 plus $1.75 per mile driven. So if you think about it, just getting in the cab, going to the store, they're probably going to charge you the full mile even if you didn't go that far. And it's still going to cost about $5.75 to go less than 1 mile. So it's about $5.75 a mile. All right, but now let's say that you're going to work, okay? And let's say you work 20 miles away. So let's see, maybe you're in a hurry, you don't want to take the bus, maybe your car broke down or something, you have to get there quickly. So it'd be $4 plus 20 miles. So just to kind of get that, that'd be 20 times $1.75. That'd be $35 total. And you would have to add the plus $4. So that'd be about $39. Divide that by 20, and it's going to be about $1.95 per mile. So it's not $5 or whatever, $5.75 a mile. So in other words, it makes a little bit more sense if you're going to have to go somewhere far away. Just because of this, what we would call a fixed cost. And this is a variable cost because the cost changes depending on how far you go. If you only go a few miles, it's, you know, you're going to get a small fee. And if you drive a long way, several miles, then that price is going to go up. That cost is going to go up. So let's go ahead and write an equation to represent the cab fare. Now for this one here, I'm going to use a very simple one. I'm going to use y equals, and we want to use our y equals mx plus b. So really, we would probably do something like if we do the order that is written, it would look something like this. Okay, but I want to make it look like y equals mx plus b, so I'm going to have to define which one is the variable cost, the one that will change, which in this case, it's going to be the 1.75. That's the variable cost. And then the 4 is the fixed cost. It does not change. It does not matter how many miles we go. We could go around the corner. We could go 20 miles. You're still going to pay $4. So this would be our formula. So let's go ahead and put what we have here. So y is total cost, and x is, oops, I could probably just say x equals miles driven. And that's all we would need to do, because it says define your variables and write an equation for what the fare would look like. So in this case here, it says if Clay's destination is 17 miles away, he has $30, will he make it? Now this one's kind of a weird one because, well, okay, where does the $30 go? Does it go where the X is or where the Y is? Because it doesn't say the word total anywhere, but you cannot spend more money than you have. So in this case, 30 would be his total. That's the total amount he can shell out. And in this case here, the fee is still the same. It's still $1.75 per mile, which in this case, actually, it says here that it is 17 miles away. Plus $4 just to have the cab show up. Now, in this case here, we're going to have to see if he has enough. Now, normally we would write an inequality for a problem like this. Normally I would. Because one side has to be greater and one side has to be smaller. And then we'd say if it's true or false, you know. Because if he has more than enough money, yes, he will make it. If he does not have enough money, then he cannot go that far. So let's see if he has enough money. So 30 equals, and then here we have 17 times 175, $1.75, because it's $1.75 per each mile, and that's going to be $29.75. Now it looks like he's got enough, but you know what? We've only calculated for the number of miles he's driven. We don't know what the full cost is going to be because there is still that $4 fee for them to come out to you, which in this case here, we must add that in. So that'd be +4. And that means the actual cab fare would be $33.75. So in this case, will he have enough money to go the trip? Because he only has $30 and the trip is going to cost $33, the answer is going to be no, he does not have enough money. Now he might have to be dropped off maybe 2 miles short of where he needs to go, but I don't think the cab would do that. I don't know, I don't know how they do that at all. I know with Uber, it's something like, I never actually rode one, but it would be something like there's like an account. So you have to pay it off. There's no walking away from it. Even if you don't pay for it right then, you're going to be charged for it later somehow. And since it's the tech companies, they'll find a way to charge you. So anyway, there you go. That answer is going to be no, he does not have enough money to make the trip. Maybe he could come up with some kind of plan or something. I don't know. Maybe he'll be forgiven. Anyway, let's go ahead and do the next problem here. So we have an example where people are purchasing a home, the Joneses. Now there's a couple of vocabulary in here that may or may not make sense, and you don't really have to understand all of this stuff here. But let's go ahead and look over the question. So again, the Joneses are buying a new home. The closing costs are $249 plus 3% of the purchase price of the new home. So there's a lot of words here that you may not be familiar with. So closing costs, what does that mean? So like you've probably heard of a phrase, something like close a deal. When you close a deal, you know, that's like, okay, this is it for now kind of thing. Now, to buy this house here, the closing cost, like I said, is $249, and that's a fixed cost. If you're buying a little home, it's still going to be $249. If you're buying a big home, it's going to still be $249. But you're also going to have to add the cost of 3% of the house. Now, a really good example of this would be something like, darn, I wish I had something in my room right now that I could use as an example. What did I use earlier? So I think I used this as my example for my last class, and that is you may have bought something on the store. So I think these are about $4 in the store. But you'll notice that if you go to, you know, the supermarket and you buy a box of Pop-Tarts and it says $4 on the box, I'm not sure if that's the real price, but you go check out and it does not have that price. You're probably going to end up paying a little bit more. If it's Tuba City, it's going to probably be like $4.32 or something like that, very close to that price last time I checked. So you are paying a certain percent extra of that cost, but you would not have an additional cost, you know, to buy that. So that's what's going on. So that's what it means by 3% of the purchase price. And purchase price is the tag price. So like in that example with the Pop-Tarts, that would be $4. You know, $4 is what it would have said for you to pay. But that's not how much you actually have to pay. That would be the total. But in this case, they use the word closing cost. Anyway, write an equation to represent the total closing cost. Define your variables. Now in this case here, I'm going to use f of x. Just, well, I could use f of x. Just because we were talking about function notation earlier. So let's use f of x. And again, you could still use y. And now we have to write the equation. So the next thing is to put 3%. Now converting percentage to decimal is kind of its own little thing. But if you imagine like 3 cents, you know, have to have that C with the slash in it. Percent and cent kind of mean like the same value. They're both out of 100. So, you know, if I said 3 cents, you know, that's how you would write it. There's a little bit more, you know, especially if you're working with other kinds of numbers. But anyway, this should be enough. So we have here our X value, because that's going to be the part that we don't know yet. That's going to be the price of the house plus $200 and $249. Now let's go ahead and identify the variables, because that's what it says to do. So f of x is going to be what they call the closing cost. Let's see what we got here. And that would mean x is going to be the purchase price. That's the word they use. So let's just keep the words the same. And again, purchase price means how much they're asking for the house, the dealership, the people that sell the house. All right, so now we can move on to our second question. I made this one a little bit easier just because it was kind of confusing, and I think it'd be a lot easier to just sort of ignore some of that. I think it had like 2 questions or something, or the wording was kind of a weird thing and it didn't really make a whole lot of sense. So I made it a little bit simple. We don't really need all that extra stuff. So the purchase price of their home is $195. And since we said X is the purchase price, that means, well, we're probably looking for the closing cost. Now, this is another term that they're saying, and that's out of pocket. And again, they switched the vocabulary because it should say what is the closing cost of the house. So when you're buying a car, a lot of times they, so let's say an example. Let's say that maybe you're getting ready to graduate and you want to get yourself a car. A car, let's say a cheap one, okay? Let's say $20,000. I think that's a fairly median price of most new cars that you, well, not new car, but first-time car owners is the word I was trying to go for. You don't have $20,000 in your pocket. Nobody does. I don't know of anybody personally that would be walking around with $20,000 in their bank. Maybe there are a few people. Maybe if you're very rich or something, you can just walk onto a dealership and buy a car like you were buying a bag of Skittles from the gas station. But most people don't have that. So what you're going to have to do is you're going to have to take out a loan. You're going to ask the bank, can I get $20,000 for a car? And they'll be like, okay, here you go. Now you take this $20,000, but I'm going to ask for some of that money back. So let's say $200 a month. Okay. Usually it's a little bit higher than that. But you're going to pay, every time you get money, you're going to give that bank a little bit of their money back. And it's going to take a couple of years. So in this example, it would take 10 years. Or if you pay $400 every month, then you'd pay it off in like 5 years or something like that. But that's a very simplified example. But in this case here, out of pocket is what you would call down payment. So in the example of the car, they would want you to pay, usually it's like a quarter of the cost or something, some percentage of the cost, usually like 30% of the cost or something like 20% of the cost, maybe even 15% of the cost. But they want money now, you know, you give them money now. So in that example with the car, they might ask for $5,000. So you need to have $5,000 in your pocket to give to them before you drive off there. So in this case, that's what they want. They want down, what we would oftentimes call down payment. So if we want to live in this house today, we're going to have to, okay, so 3%. So that 3% of 195,000 is going to be 5,850. But we still have to pay that for $249 fee. And this means here that I'm going to add 249, and that's going to be $6,099. $6,099. And this is what they're going to have to pay to live in that house now, because, you know, they probably want to move in and start working a new job. And that's usually the way it is for most Americans. for most Americans. You know, they look for the job first and then they move there. And a lot of times they'll switch jobs, and a lot of times they'll move into other cities and stuff like that. So there's a bunch of other things that would have to work on. So that would be the cost. So they would need about $6,000 in their pocket to be able to just give to the dealership and say, here, this is like the promise. So even if we move out of the house, you still certainly keep almost that much money. You would still have $6,000 to, you know, give to your employees, pay for your store to stay open. All right, so anyway, that was a fairly complicated example, and it was just mostly vocabulary, but a lot of it's just pretty simple. It's just the same, y equals mx plus b, plug this in, and stuff like that. But I hope you learned a little bit about something about buying large items. Because I know a lot of people will always say something like that. They'll be like, oh, I've been in school for all this time and no one's ever taught me how to do blank and blank. Usually it's taxes. And trust me, the government doesn't want you to learn what happens to your taxes, because if you did, you wouldn't like it. I shouldn't have said that. Now they're going to be after me. Anyway, so here we go. A 22.5 ounce candle burns at a rate of 1 ounce every 5 hours. Write an equation to represent the amount of candle left. Define your variable. So I'm going to use y. This is a fairly simple example, so I might just use y. And you can use x, y, whatever you think. And let's see. And I want to put it in y equals mx plus b, but I think a lot of people would probably start with the actual value first. In fact, I think I'm going to do that with this one, and just because. This one is a little bit of a tough example because there's two things that are a little bit different. One, if you think of a candle, the longer you burn it, the shorter it gets. So this is actually a negative slope. Not only that, but there's a really tricky thing where it says right here, a rate of 1 ounce every 5 hours. And I'll put C for candle. And that means that in every 5 hours, 1 ounce every 5 hours, that means you're going to have 1/5 H. So if 1 hour goes by, you burn 1/5 of an ounce. And again, that's a bit of a tricky thing. I mean, maybe you'll understand it pretty easily, but I think most people would probably think about that. And you know, if I said 1 ounce every 5 hours, they'd put 5H there. But again, in 5 hours, it'll burn 1 ounce. In 2 hours, it'll burn, or sorry, in 10 hours, it'll burn 2 ounces. So it does require a little bit of thinking. Now C, I'm gonna just say that C is candle length or candle size, and H is hours. I'm gonna keep it kind of simple. And it says, how many hours will the candle last? And this is another tricky one here. Because the input is not stated. It doesn't say, you know, how many hours will the candle be 1 ounce? You know, how many hours will the candle go halfway? That would be a little bit easier to kind of tell what number you're supposed to put in there, but in this case, it doesn't really tell you anything. It just says, how many hours will the candle last? So to do this one here, let's go ahead and take our formula again. So I'm going to take our formula. And what I'm going to do is I am going to switch over to my calculator. Oopsie. Let me switch over there. Okay, now I have 1/5, right? Because again, it burns 1 ounce every 5 hours. So that would mean that I would need to put in 0.2. And I'm only doing this to make it go a little bit faster, a little bit simpler maybe. So that means I'm going to convert this fraction into a decimal, which you can do sometimes. You can do that sometimes. Sometimes you shouldn't do that. And in this case, I am going to go ahead and do that just to make it go a little bit easier. All right, so now next thing going on here is we are going to have to solve one of these variables. So the question is, which one do we know? Do we know the C or do we know the H? So it asks us how many hours. So that's a clue that that's what we're looking for. So that means that we need to plug in something for C in order to solve this. But what can we put in for C? Now, when a candle cannot last any longer, that's because it has zero wick, zero length left. So in this case, again, it doesn't say the word zero in there, but we kind of have to just sort of know that's what it's looking for. All right, so now I am going to go ahead and add, I'm going to add some of these numbers together. So I'm going to add 0.2H to both sides. And that should give us the next thing we're looking for. So this would be 0.2H equals 22.5. Now again, it burns 1/5 of ounce every hour. So if I divide this by 0.2, and that's going to be another really tough one, but I mean, you could easily have done this with a fraction. You'd have to do the trick where you'd use a reciprocal. So 22.5 divided by 0.2, oops, not that many, so 0.2, no extra zeros in there. And in this case here, we get 112 hours. So that's like 4 days, maybe a little bit longer than 4 days of, 4.5 days maybe, 4.5 days of burn time, which is, I don't know if that's really, well, the candle is measured in ounces, so maybe it's a pretty big candle, I don't know. But anyway, we have our answer, 112.5 hours of burn time. That's how long this candle will last. Okay. All right, so that's it for that one. This one is not a really tough example if you know what you're looking for, but again, it's kind of hard getting context from questions like this. All right, so now with these ones here, this one's kind of a weird one. It is in standard form because remember, in standard form you have an x, so that's ax plus by equals c. So it doesn't actually, or it does say it on the packet. On the packet, it does say you are dealing with standard form. So again, you're dealing with two items now. And in this case here, the C is still going to be the total cost. So we got our guy, Josh. He bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost. Define your variables. So again, this one's in, I might as well just put it up here, just so that way we have it. AX plus BY equals C. So there's 2 things we're looking at in this case. So A value, so now this one's a bit of a weird one because normally when we're calculating the cost, we know the price. But in this case here, well, it says he has 3 bags of potting soil and 10 bags of mulch. So we know how much he bought, but we don't know how much they cost. So it's just a bit of a weird thing that this one's asking for a slightly different thing, but don't worry too much about it. Just use what you know. So we'll go with C is for cost because that's what it says. C equals 3, and I'm gonna just say P for potting soil plus 10 M. And it says to define the variable. So C is total cost. P is potting soil. And M is mulch. So I'm gonna have to find a way to fit all this together. There you go, that works out better. So there you go, now we know what we're looking for. We've identified our variables. So let's move on to the second part. Now this is actually the same question, it's just different steps. So here it says Josh spent $40.91. the mulch cost $2.75 per bag. How much was the bag of potting soil? So in this case, again, this is our clue that we're looking for potting soil. So in this case, P is what we don't know. Now in this example, maybe he remembers how much he spent. So maybe he got home and was like, darn, how much was the potting soil? I do remember the mulch said it was $2.75 because it was a big sign and it was on sale. I know that I spent $40.91. So then he's gonna have to kind of work backwards from there. So we know that the C is the total cost, so that's $41.91. We know that we're looking for 3P, we're looking for potting soil, so we know that's what we don't know, plus 10M, which in this case, he knows that the cost was $2.75. So there we go. We got everything set up. And again, there's only going to be one thing that we're looking for. So 3P, and I'm going to go ahead and multiply this together. Actually, this is pretty easy. It'd be $27.50. And since we're talking about dollars, I'm going to put the extra zero in there. Normally I would not put the extra zero in there because it doesn't really do anything. So now I'm gonna have to minus $27.50 from both sides, because what I'm doing is, we know he bought $10 of mulch at $2.75 a bag. So this means that we know that he spent $27.50 in total on mulch, but we don't want to know how much mulch he did. So we're taking that off. We're taking that off of his total. So we'll take that off, $27.50. And in this case, we get $13.41 for buying 3 bags of the potting soil. So now we know that there's $13.41 in potting soil. Now I'm going to have to divide this by 3. And now we know how much it is. It's $4.47. Which that, again, makes sense. Actually, I don't know. Well, potting soil is pretty expensive. I should really write that whole thing down. Still not going to fit. Okay, fine. That's going to have to do. No, I should say potting soil, but I can't put any more stuff in there. But either way, we got it now. So we know that it's $4.47. So if he has to go back to the store, he knows how much he might spend. All right, next one. Kaylee has a collection of quarters and nickels. All right, so I've been using C a lot, actually. C is cost, C is cost or candle. I could put C for coins, because in this case it says Kaylee has a collection of quarters and nickels, but I'm going to use K. I'm going to be a little bit different and put K there because we're talking about Kaylee's, what she has. Write an equation to determine the total value of the coins and define your variables. So it says quarters and nickels. So we know that a quarter is this much. And that would be, so if you have 1 quarter, that's 25 cents. If you have 2 quarters, that's 50 cents. 3 quarters, 75 cents, and so on. Now, in this case here, we would have nickels. So I'm going to show the value of a nickel. And that's N is for the number of nickels. So if we have 1 nickel, it's 5 cents. 2 nickels is 10 cents. 3 nickels is 15 cents, and so on. Now, it says to define your variables. So Kaylee, so K is Kaylee's amount. Again, just because I don't want to use C for a 5th time in a row. And Q is quarters. Oops, Q didn't show up there. Weird. And N is nickels. There we go. Now let's see, the total value of the coins is $5.50. And again, we said that K was Kaylee's amount, so $5.50. And that would it would have to go by how many quarters she has, which in this case there is 17 quarters. And the question is, how many nickels does she have? That's what we don't know. So that's going to be the part that stays in there for n. So starting with our formula, let's go ahead and try to solve this. So I'm going to go ahead and multiply 25 cents times 17 because we want to know how many quarters, how much value of quarters she has, which in this case is going to be $4.25 in quarters. Oops, N, not M. And this means I'm going to have to minus, I'm going to subtract 425 from both sides because I don't want to know how many, I mean, we know how many quarters she has, so we're going to take that off. We're going to ignore that. So that's going to be 125. So she has 125. If we ignore the quarters, looking at only the nickels, she has $1.25 in nickels. Now we could divide this by the value of each nickel, and we could easily tell how many nickels she has. So I'm going to divide both sides by 0.05, and we've already worked with a little bit of decimals, so that should be not that bad. You could use a calculator for this one. If not, you're going to have to remember to move the decimal out of both numbers when you divide, and you would get 25 nickels. So there you go. We were able to say how many nickels that she actually has. And that's pretty good. Let's go ahead and move on. Get ready to move on to the next one. And I think this next one is going to be pretty much the same as these other examples that we've had, the recent examples, the number 10 and 11. Anyway, so here we have a baseball concession stand. Sells soft pretzels for $4.50 and bags of popcorn for $3.25. Write an equation to represent the total sales from pretzels and popcorn on a given day. Okay, so we got to assign things. And usually when I do word problems, I like to be specific about my variables in case I need to go back. You know, don't just use X and Y and say X is pretzels and Y is popcorn, even though that does make sense and you can do math stuff with it. You know, in a real example, you might have to know like, oh shoot, how many bags of popcorn do we have or something like that. And it'd be a lot easier to say, okay, well, P is already popcorn. So it's pretty easy to go back and look at it. So let's go ahead and do this one. So I'm going to use T for total sales. I must put C for cost of concession or something like that. Or so I'm going to use T. So that's going to be, the first one they give us is $4.50 for pretzels. Now they say soft pretzels, and the problem would have been with this next one, and that is $3.25 for popcorn, which if I picked P for pretzels, then I'd have two P variables, which I don't want. So that's why I had to kind of make pretzels soft pretzels. Plus that too, you know, if somebody came up to me and was like, do you want a pretzel? I'd be like, what kind is it? Because I really don't like the ones that come in the bag. They're too salty. They're too crunchy. They don't have a lot of flavor. And I don't know, they sound really loud in your, when you crunch them. So I don't like them. But if someone said, you want a pretzel? And they said soft pretzel, I'd be like, heck yeah, you got nacho cheese with that? I miss the theater. Anyway, so there you go. Define your variables. So T is, we'll say total sales. Oopsie. How the heck did that come out? Total sales. And then let's see, S is pretzels. We don't need to get too, how do you spell pretzels? Okay, and then P is popcorn. Con. There we go. And let's see, there we go. So now we have all three of our variables sorted out. And we're going to use the same one to get the next thing. So if the concession stand sold 137 soft pretzels, how many bags of popcorn would they need to sell to make at least $1,000? So let's say that's our goal. Okay, we got to make $1,000 selling these two items. Now, why this might work, why this might have to work out this way, maybe that's because these are donated items, okay? Maybe somebody gave away bags of pretzels from Sam's Club and popcorn or something like that. So we don't need to worry about any of the money that we spent to get this stuff because it was free for us basically. And maybe we have two teams. Maybe we have one side selling pretzels and the other side selling popcorn. So it's a little bit tough to tell exactly how much we have. But again, that's our goal. We want to know if we can get $1,000. And the pretzel people are on top of it. You know, they mark down easily how many pretzels they sold. Well, maybe it's a little bit easier to count pretzels because if they come in bags of 50 and you already sold 2 bags and you're partway through the 3rd bag, okay, you just count what's left and now you can see how many you have. So they're on top of it. They know that they have 137 pretzels sold. So let's go ahead and put in 137 right here. But the popcorn people, because popcorn is harder to count, and maybe it sells a little bit faster, usually, that's just kind of what I noticed. Maybe they don't know how much they have to, so they'd have to go back and count how many bags they have left. So they'd have to know how many bags they have and how many they have left and how many came in the box and then do some subtraction or something. So it's gonna take them a little bit more time to do that. Oh, you know what? I actually put this in the totally wrong place almost. I need to put that here because popcorn is what we don't know. Because that's the question. How many bags of popcorn would we need to sell in order to make at least $1,000? So make sure we put that in the right spot. And again, that's why I said it's a good idea to have the variables labeled clearly. All right, so there we go. Now, looking at how much money we made from only the pretzels. So that's $4 per pretzel, $4.50 per pretzel for a pretzel. And that would mean that we have spent, or sorry, we have brought in $616.50. So that's how much money we got from the pretzels. And again, the popcorn people, they're probably still counting how much they sold. So what I'm gonna have to do is take off, because we know we have $616 in pretzels. So now we gotta take that off of 1,000. So that means our goal is gonna be a little bit shorter to get to, which in this case here, that means in order to get to 1,000, we'd only have to sell $383.50 of popcorn in order to get there. And again, I'm gonna go ahead and divide both sides. So 383 divided by 325, and that's gonna be 118 bags. Now, chances are, and this is again, just from what I know is from concession, popcorn is usually one of the best selling items. Popcorn is actually kind of hard to get. I think that's why, and it's best to have it fresh. I mean, you could go to like one of the convenience stores and buy popcorn, but nothing beats the fresh smell of popcorn, like at a movie theater or somewhere. So usually, and it's usually pretty cheap. So in this case here, I would pretty much be certain almost if we sold 137 pretzels and if we could sell almost that same number of popcorn, which again, popcorn usually sells better, I'm pretty sure we would have made the goal if this was us. Okay, now I don't remember what I included in the packet. So this next part, I'm not sure how useful it is because I don't remember if I put it in the packet or not, but I guess it's always useful to kind of go over. So I'm gonna kind of go over it pretty quickly. So we're going to talk about scatter plots and correlation. So a scatter plot shows a relation between two variables. And right now we got to sketch the 3 possible relations here. So I don't remember if I included this worksheet. Maybe I did, maybe I didn't, but again, whatever. It's part of the lesson. So positive correlation is something now in real life when you look for data, okay, when you're looking at something, what you could be looking for is correlation. Now be careful because a lot of times people on the news will say, well, there's been a correlation, and they might say something along the, I'm gonna use a classic example here. They might say, well, we did a research study and we noticed that when the temperature is higher, crime goes up. There is more crimes when there is higher temperature. Now, does that make sense? Maybe it does. But actually the other thing is, what if they said, ice cream sales go up as the day gets hotter. Well, then someone might say, well, does ice cream cause crime? No, that's absurd. Just because you sell a lot of ice cream doesn't mean people are going to go out and break windows or steal cars or whatever. That doesn't make any sense. So just because there's correlation does not mean that they cause each other. So a lot of times people will look and say, okay, well, we noticed that this changed, and this is, one of the other outcomes that we have. So that would be an example of positive correlation. And then you also have negative correlation, which means whatever you're measuring, it goes, as whatever you're measuring increases, whatever the outcome is going down. So there's another really good example for this one that I'm going to save. And it's not a perfectly straight line, and these dots are kind of all over the place, but you can kind of see that in general, it's kind of going down. No correlation would be something like this, where if you had to draw a line through it, it would be kind of hard because, well, the line isn't really going anywhere. There's nothing going on. There's just absolutely no way you could draw a relation with this. It's not going up, not going down. It's just all over the place, randomized. And then you have a line of best fit. So this is what you would use for like an equation or something, and you would use it to predict the value. So you can use it as sort of a prediction tool as well. So again, just fill in some of those dots. That's all you got to do for this one. Now let's get to the last slide that we're going to be working on. And again, this is useful information to kind of go over. So here we have a table, and it says that there is a relationship between the depth, which they mark as D, and the depth of the lake in feet and the water temperature of T in Fahrenheit, T degrees. So T is temperature, D is depth of water. So let's go ahead and fill in some of these areas. So I have 0. So this is the depth of 0, which means it's like the surface of the water. So if you were to grab, a thermometer and measure the top of the water, in this case, it would be 85 degrees. Now in this case here, I kind of had to skip a few. I couldn't really fit it in because I wanted to make sure this part fit with 25 feet for part C of this. So I'm going to kind of start from the backwards. So 15 to 76. So 15 would be right here, and 76 would be, okay, wait, hold on. So each of these are about 5. So 15 would be right here, and that would be 76. So it's a little bit above there. And then here I have 12, and that'd be 77 degrees. So this would be maybe right about here. And then 10. So at 10 feet down, it would be 79 degrees. And then at 7, it would be 81. 7 would be 81, and I think here the next one would be 4, and that would be 82, which would actually be like right over here somewhere. Now again, this is not a perfectly straight line, okay? Water does not immediately just go, say, oh shoot, I'm 5 feet down, I need to be this temperature. Okay, water does not do that. So it's not going to be a perfectly straight line, but you can kind of see that there is a way to kind of get this. There is kind of a way you could generally see a line that kind of goes down like that. And it says to use 2 ordered pairs to write a line of best fit. So let's go with 2 lines. Let's go with this one and this one. Okay, so we're going to use the same thing we did earlier. We have an ordered pair here and an ordered pair down here. So we can treat this like it's a Y and treat this like it's an X. So 79 minus 85. And then over here, I'd have 10 minus 0. Because again, I'm looking at the X. So X2 minus X1. 79 minus 85, that would be 6. Bottom number would be 10. So this means that it would be, well, let's keep it as a fraction. And actually, in this case, it would be negative because this would have been, we're minusing 85 from 79. Also, you can tell that it should be negative because the line is going down. This is negative correlation. And that makes sense because the deeper into water you go, the light doesn't go down as deep, so the light is not warming up the water. So if it's deep water, it's probably going to be very cold. Now let's go ahead and plug in one of these, so y minus, and I'm going to have to use the y value. I'm going to go with this one here, so y minus 85 equals negative 3/5 x minus, and then the value that goes with that one is 0. And that makes it pretty easy because I don't have to do a lot of multiplying, because negative 3/5 times 0 is going to be 0. There's not going to be anything there, which makes it really easy to add a number to, which in this case I need to add 85 to that number. And again, you could get something a little bit different. You could get a number that would be close enough. And because again, water does not behave perfectly, by temperature and depth. You might get something a little bit different if you pick any of these other numbers, because any of these other numbers will work out. But anyway, there's our line of best fit. This means that this is what we can use to predict any depth. Okay, so maybe we don't have a way of measuring the water 25 feet down. Okay, so 25 would be about, let's see, from here to there is 15, so it'd be about right there. So looking at our graph, which again, our graph does not have all of those numbers, it might be about, it could be anywhere from about 65 to under 70 degrees is probably my guess. So to predict the temperature of the lake at 25 feet, let's plug in x as the depth of 25. So y equals negative 3/5 x, but we know that this is going to be 25 plus 85. So now we will know the temperature. We will know the y if we can plug this in. So 3 times 25 is 75. 75 divided by 5 is 15, I believe. 25 times 3, divide that by 5, and it is indeed 15. Oops. So that would be y equals negative 15 plus 85, and y equals 70. And like I said, it's going to be, my guess was a little under 70, but like I said, 65 to 70. So that actually makes a lot of sense, that it would be about 70 degrees, and our graph isn't perfect, and this line isn't going to be perfectly straight either. If it's realistic, it's not going to be perfectly straight, because there aren't really a whole lot of things that will be perfectly straight in real life. Anyway, so that's it. That's all we wanted to do. That's it for today, I guess. So I'm going to go ahead and wind this down. So I know people are always saying things in school like, oh, I graduated school, but I don't know how to do blank. And usually they'll always say something like taxes, or I don't know how to do money. But, there is sometimes things you can use, but all this math doesn't really do you any good if you don't know how to use it. So you always got to learn how to use the math, right? So don't be one of those students that say, I'm good at math, but not word problems, because if you are good at math, but not good at word problems, then that means you can't use math in real life. So it's not really going to help you at all. So you are going to feel like, oh, I learned a bunch of useless information. All right. So I try not to do that. Anyway, thank you for stopping by today, and I will see you later. Bye-bye.
Okay, bye.